Welcome to this video about using the SimpleFOCShield in combination with the STM32 black pill. This is a fast, cheap Arduino compatible microcontroller. I'm also using a BLDC motor and an AS5600 magnetic sensor. Here I've made a diagram about the working principle. Orange stands for electrical, black stands for hardware, and green stands for software. Here you can see the bottom of the shield. You can see that PWM-C, so that means the PWM signal for phase C, is connected to pin 6. Pin 6 is then connected to PA7 of the STM32 black pill. You need to choose pins that have PWM capabilities. For the current sensing, it's basically the same, but you need to do analog reading. I've connected the sensor through the shield because this has female headers, so it's easy to use. Here you can see the connections that are made on the PCB. As you can see, the sensor is connected through the board. Here is the 5208 motor. This is the size of the motor. And here you can see the 3-phase wires that are connected to the shield. The encoder is a magnetic encoder. The magnet here rotates with the rotor and rotates above the sensor, and that's how it measures the angle of the motor. Now we're going to take a look at the software. So we're making a BLDC motor instance that is called motor, and I'm entering the pole pairs. For the sensor, I'm also making an instance, this time of the magnetic sensor I2C, and this is called sensor. I'm entering AS5600_I2C because the library knows the sensor. You can also manually add sensors or use other types of encoders. For the driver, we also need to make an instance. This time it's the BLDC driver 3 PWM. This is because the shield uses an L6234D chip, and this has 3 PWM pins. Here you need to enter the pins that you've chosen above. We also need to make an instance of the current sensing. The shield uses inline current sensing, and our instance is called current sense. And here we can enter the 2 pins that we've chosen here above. You can also use your PC to send commands to the microcontroller that the motor needs to do. This is the commander interface, and we can also make an instance of that. Then we need to initialize the sensor, link the sensor to the motor. That's what's happening here. We need to set the power supply voltage, initialize the driver, link the driver to the motor, and also link the driver to the current sensing. That's what you can see here. You need to choose a motor controller type, a torque controller type, and an FOC modulation type. This also depends if you use current sensing or not, or even open loop. We set a current limit for the motor and initialize it. Then we initialize the current sensing and link the current sensing to the motor. That's here. This link explains why this needs to be placed here in the code. Then we need to initialize the FOC. This also aligns the encoder and the current sensing. And we need to subscribe the motor to the commander interface. In the loop, we have loop FOC, motor.move, and command.run. This loops the FOC function. This needs to be run as many times as possible. The motor.move actually moves the motor to the desired position or velocity or torque. And this checks if there is a new command from the commander interface. To program the microcontroller, you need to use these settings. I will also place a link in the description that explains how you need to use these buttons to program the microcontroller correctly. Now I will do a demonstration. I plug in the power, plug in the USB cable, the MCU starts and the motor aligns. Now I'll enter a torque command. As you can see, it's not so strong, so I will increase the torque. The command looks like this. Now it's a bit stronger, but I will increase the torque again. And now I will put the torque to 0 again. This is my second video about the SimpleFOC project. I've also made a website, SimpleFOC Generator. This automatically generates the code for your hardware. You just need to enter your hardware and settings. I'll place the video about that on the end screen. That was it for this video. I hope you enjoyed. Please consider subscribing and I will see you in the next video. Thanks for watching. Bye.